right, so yeah, so this one's all about lingo. So there's this function h that we're interested in, and there's this function f that we're given. These are two different functions, and they have something in common with each other. But they're not the same function, right? And they're connected by way of the fact that they both relate to some, surface, the same, or it's not a surface. It's so whatever this object is, that is that they have in common, right? But they have this shape in common by way of different constructions. So this thing is one of the level sets of H, right? But it's the graph of F. Okay. All right. So we got to worry about that as we go through the problem. So I'm going to start with what we're given. We're given function F, and we're interested in the graph of that function F. So let's write down, how can I represent the graph of this function F? All right, well, F has 4 input variables, x, y, z, and w. The graph is what I get when I take that formula and we know the formula, it's x squared minus y cubed plus 5z squared plus w to the 4th. Take that formula and we set it equal to, here's what graph means. Graph means we set that equal to some other variable. I can't use z. It's an input variable. I can't use y. I can't use w. So I'll think about the alphabet. I can say v, I guess, right? Okay, so I'm going to create the graph. So the graph is what I get by setting those values equal to a new variable, like so. Okay, everybody good so far? All right, now I'm interested in some other function, and this other function h has the feature that function h, one of the level sets, is this exact same thing. So let's talk about what does a level set of h look like. Right, well, a level set of h looks something like this. H equals a constant. Equals a constant is what level set means. All right, so still don't know what h is, but here's just sort of an algebraic version of what I'm given. The graph of f is described by that equation. A level set of h is described by that equation, and these two equations apparently represent the same geometric object. So they're equations for exactly the same thing, and that means that these two equations are equivalent. So they're the same equation, it's just, with maybe terms moved around in different ways. All right. So now you just have to sort of figure out how can you manipulate these equations around so that, in fact, this happens. So what is it that I can do, that is, what can I do to this equation to get stuff equals a constant? All right. Well, I could do this. I could say x squared minus y cubed plus 5z squared plus w to the 4th minus v equals 0. Now, these... Yeah, no problem. See you guys. These two equations are equivalent. They're exactly the same equation, except that I've moved v to the other side. So these two equations here definitely describe the same surface. And having rewritten that, I could say, oh, well, you know what? I could just decide that my constant is 0 and that this function h that I'm looking for is that function, right? And now, if you think about it, this equation on the left, now that I've chosen h to be the left side of that equation, the equation on the left describes a level set of my chosen h. The equation on the right describes the graph of the given f. And the fact that these two equations are equivalent means that these are the same objects.
And then the domain would be 5 or...
Yeah. So now, sorry, I forgot the second half of the question. So this function is h of, let's count input variables. H is a function of, x, y, z, w, and v. So yeah, there's 5 input variables, x, y, z, w, and v, and it's equal to, all that business. And so yeah, h is a function from R5 is the domain. And by the way, how many outputs does H have? Well, just one output. So R5 to R1.
Will most level sets be in R1?
The notion of a level set is most useful when the target is R1. Yeah. Right. Most of the time. Not always, but most of the time. Yeah.
The reason why it's R1 is because it equals a constant.
Yeah, well, I mean, it could be a constant vector, and there are some situations where it would be natural to do that. It's just that we're going to make the most gains, or most of what we're going to do with level sets is where we consider it to be a constant number. Yeah.
So would that whole h, x, y, z, w, v equal 0 in this scenario?
So no. So the function itself. You'll notice I did not include 0 there. Okay. So the function h, highlighting, this function h is equal to that expression. So if you ask what is the function h, it's equal to that expression. Now, if you then ask the different question, what is you okay? Okay, yeah. What is one of the level sets of h? That's when you set that equal to 0. But h itself is not. I mean, here's the silly thing. Let's imagine if h were in fact actually 0. Mm-hmm. Then when you set h equal to 0, you wouldn't get a surface. You'd get all of R5, and it just doesn't make any sense. Yeah. Right. So this is where you have to distinguish between what is the function and what is an equation that describes a construction related to that function, and how they're very, very different things. Okay. Cool. All right, let me stop this recording.